Hello everyone. In today's video, I'm going to show you how I solve the minimum deletions to make character frequencies unique on Leetcode. Before that, please hit like and subscribe to my channel. It will help me a lot. Thank you so much. Let's get to the question. So a string S is called good if there are no two different characters in S that have the same frequency. Given a string S, return the minimum number of characters you need to delete to make S good. The frequency of a character in a string is the number of times it appears in the string. So A, B, A is 2, B is 1, okay, that looks simple. And A, B is good because A frequency is 2 and B frequency is 1. So let's look at the code, how I solve it. So in this kind of question, what you want to do first is like you need to know the frequency, right? So just the normal basic for loop through all the string in the all the characters in the string and then keep it in the map. So we know how many of them per characters. You can, I think, in here you can also use an array because it's going to be 26 characters anyway, so doesn't make any difference. And then after that, what I do is from the map I get the key, and we're gonna get only the characters that appear in the string in this case. And then for each characters, what I'm gonna do is first I'm gonna get the values, that's the frequency of that characters. And then I have the F array, which is the frequency array. The index will be the frequency. So I check if the frequency at the value is not there, so no one have this frequency before. I just create an array. If the index else, I just say, hey, this index is kind of an object that I just want to keep track of which frequency actually have the duplicate. That's the one that we need to actually work on to delete, right? And then I just pushing the letter to the frequency V. After this is done, what we're gonna get is we're gonna get an array F with some holes in there, and then at some index we're gonna have multiple things in the array. It's like multiple characters. So what we want to do next is we need to try to spread it out. What I want to do is we're gonna go from the higher number. So what I do here is after getting the key of the index. So you can see the key of index is actually the frequency, right? So we sorted it in descending order. So we can start from the highest frequency to the lowest frequency. So I just get the count from the f index dot length minus 1 because we just need to move the thing that's more than 1, right? We have 1 is fine. So that's the count. And then in this while loop, because we know that we can only move until the frequency. For example, if frequency is 3, you cannot move beyond 3 because you can delete at the maximum 3 characters. That's why we have the check at index minus I must be greater than or equal to 0. And I don't need to have this check because I must be less than index because of this anyway. And then the count is greater than 0. So if we still need to move something, we still have the count. So what I'm doing here is, so I'm checking if index minus I, so move to the left. Oh, if this frequency, for my example, was we start with 3, so and I start with 1. So if frequency at index 2 is available, we just make sure that that index is setting to some value, because we just check this one. We don't need to do any different. We just mark it as okay, it's used. And then we can say, hey, result, you want to add I to the result. That means if you move 2 steps, you need to delete 2 characters. So we add that to the result, and then we decrement the count because okay, this one fall into the good place now. And after that, we just increase the I. And then if the while loop ends and we still have count here, so we know we need to delete all of the characters that's left because we cannot find anything within the range. So we can just do the count multiplied by index and then add to the result. And that's it. You get the result and then just return it. Let's run it. Oh, I got 100% faster and 100% on memory as well. So in this case, let's look at the time complexity. So I loop through the whole array, so it's all n here. And this object is a key map. Map is actually, the key of map is maximum is 26, right? Because the number of characters. So it's gonna be O of 1 because maximum is 26, is constant. Same here is the number of keys is maximum 26, but it's kind of impossible. It must be less than 26. And then we sorted, it's supposed to be n log n, but since n is constant, so it's still constant term. And then this one, we loop through it at most 26 by 26 if you want to think about it that way, but it's still constant term. So at the end, the whole thing gonna be big O of n just because of this loop. Okay, that's all I have for today. Thank you so much for watching.